नमस्कार विद्यार्थी मित्रांनो. आज आपण सुरू करणार युनिट 3 कॉम्प्लेक्स इंटिग्रेशन. नाव it turns towards the examples. This is the example first. Evaluate integration over c x square plus y square plus minus ixy dz, where c is the line segment from z is equal to 0 to z is equal to 1 plus I. Okay, now we have to take the integration over c, where c is a line from z is equal to 0 to z is equal to 1. Z is equal to 0 means it is the origin, and z is equal to 1 plus I means it's a x coordinate is 1, y coordinate is also 1, because imaginary part is 1, real part is 1. So this is a point 1 1. So x coordinate is 1, y coordinate is 1. So line from 0 to this point is nothing but it's the line segment from z is equal to 0 to z is equal to 1 plus I. Okay. Now we have to take the integration over this line. So as C is a straight line, its a parametric equation is x is equal to t, y is equal to t. So z is equal to complex number x plus iy. So it can be written as t plus it. If we put x is equal to t, y is equal to t. So f of z becomes x square plus y square plus minus ixy. So put x and y is equal to 2, so t square plus t square minus it square. That is a 2t square minus it square. So dz is equal to dx plus I dy. So dt plus I dt. So 1 plus I dt. So putting all these values, this integration becomes integration over c f of z dz is equal to. So here t is from 0 to 1. Here t is varies from 0 to 1. So put these values. F of z is nothing but 2t square minus it square, and dz is nothing but 1 plus I dt. So 1 plus I is a common because it is constant. Take it outside. Integration from 0 to 1, 2t square minus t square I dt. So integration of t square is t cube by 3. Any limit varies from 0 to 1. So put the first limit, that's 1 by 3, minus second limit is 0. So 1 plus I into minus 2 minus 1 plus I into 2 minus I into 1 by 3. This is our integration. Take the multiplication of 1 plus I into minus I. That is the 2 plus I minus I square. I square is minus 1. So minus minus plus 1. So 3 plus I upon I. This is the answer. Now second one, evaluate the integration over C z dz, where C is the arc of the parabola y square is equal to 4ax from 0 0. That is the origin to a to a. This is the point to a. That is the x coordinate is a and y coordinate is 2a. Now this is the origin. This is our arc of parabola. Y square is equal to 4ax. The parametric equation is x is equal to at square, y is equal to 2at. Uh, t varies from 0 to 1. So z is equal to x plus iy. Put the value of x is equal to at square and y is equal to 2at. So dz is equal to 2at plus 2ai dt. So integration over c z dz becomes integration varies from 0 to 1, because t varies from 0 to 1. Put the value of z, that is at square plus 2at I, and dz is nothing but 2at plus 2ai dt. We can take 2a square common throughout, so it becomes limit 0 to 1 t square 2 ti into t plus I dt. Taking multiplication of these two terms, so we get integration varies from 0 to 1 t cube minus 2t plus 3t square I dt. and integration of tq is t raised to 4 by 4, integration of t is t square by 2, integration of t square is t cube by 3. So it becomes, and limit varies from 0 to 1. Put the first limit 1 by 4. If you put t square, first limit is 1, so 1 square is 1, there's a 1. So 1 by 4 minus 1 minus I, and say if you put second limit t is equal to 0, then it becomes 0. So this is 2a square into minus 3 by 4 plus I. This is our answer. Next example, if f of z is equal to y minus x minus 3x square I, evaluate integration f of z dz over c1, where c1 is a straight line segment from 0 to 1 plus I, and if, we have to integrate this f of z dz over c2, where c2 is the consists to a straight line segment 1 from z is to 0 to z is z is equal to I, and then from z is equal to I to z is equal to 1 plus I. Now for the first segment z is equal to 0 to z is equal to 1 plus I, c1 is a line segment from z is equal to 0 to z is equal to 1 plus I. Now parametric equation is t plus it, where t varies from 0 to 1. So x is equal to t, y is equal to t. So it becomes, therefore dz by dt becomes 1 plus I, and f of z is equal to t minus t 3t square I. So minus 3t square I, this is our f of z. So putting these values, we get integration over c1 f of z dz is equal to integration varies from 0 to 1 minus 3t square I into 1 plus I dt. This is the value of dz. So here 1 plus I and 3 minus 3I, these are the constant, take it outside the limit, so it becomes limits varies from 0 to 1 t square dt. Limit of t integration of t square is t cube by 3, and limit varies from 0 to 1. Put the first limit 1 by t cube, t ची value taka 1, so 1 cube is 1, so 1 by 3 is the first limit, and if you put z t is equal to 0, then the second limit is 0. So minus I 1 plus I into 1, so minus I into 1 plus I, that is I square, I minus I square. There's a I square is minus 1 minus minus plus 1, so 1 minus I, this is the answer. Now the first, take the c2 is the C4 and C3 and C4 denotes the line segment from 0 to Z, Z is equal to 0 to Z is equal to I. This is the first line segment, Z is equal to 0 to Z is equal to I, and then Z is equal to I to Z is equal to 1 plus I denotes C4. So C2 is nothing but C3 plus C4. So integration over C2 is nothing but f of Z dz is nothing but integration over C3 f of z dz plus integration over C4 f of z dz. So by calculating this, we can calculate separate for this. So x is this C3 is nothing but y axis, so it becomes x is equal to 0. The equation of y axis is x is equal to 0. So integration becomes integration from 0 to 2 pi e raised to I theta raised to n I r e raised to I theta d theta. It is the polar form of complex number. I r raised to n plus 1 is common because it is a constant. Integration from 0 to 2 pi e raised to I n theta e raised to I theta d theta. So it becomes e raised to I into n plus 1 theta, and I e raised to I n theta is integration e raised to I theta just divided by the derivative of e raised to I theta, that is I into n plus 1. Limit varies from 0 to 2 pi. Put theta is equal to 2 pi here, so e raised to 2 pi I n plus 1 theta into e raised to 0, e raised to 0 is 1. So and again e raised to 2k pi I is nothing but 1, so this is 1, this is 1, so 1 minus 1 is 0, so it becomes 0. So if n is equal to minus 1, then it becomes integration of 0 to 2 pi 1 upon z minus a dz. So it becomes integration of 0 to 2 pi 1 upon r e raised to I theta into I r e raised to I theta d theta. That's the integration 0 to 2 pi d theta. Integration becomes 0 and limit becomes 0 to pi, that is I into 2 pi, that is 2 pi I. This is the answer. So hence integration over c to z minus a raised to n dz is nothing but 0 if n not equals to minus 1, and it is 2 pi I if n is equal to minus 1. Now in the next theorem we have to see the Cauchy's integral theorem.